Greetings, 6th grade parents and students. Mr. Korn here. Today's video is going to be about unit rate. What is a unit rate? What's the definition? And how do we find the unit rate? First, let's start with the definition of a unit rate. A unit rate is simply a ratio where one of the numbers in the ratio is a 1. This example right here, 15 pizzas to 5 groups. So suppose I was having a pizza party and I got 15 pizzas for 5 groups of people. Okay? This is a ratio because it's a comparison of the number of pizzas to the number of groups. 15 pizzas to 5 groups. But remember, a unit rate is a ratio where one of the numbers is a 1. This is an example of a unit rate. A unit rate is still a ratio. It's still a comparison of two quantities or two numbers. But remember, one of the numbers has to be a 1 to make it a unit rate. So 3 pizzas for one group is a unit rate. And unit rates can help us solve problems. How many pizzas for each group? Okay, so this is the difference between a regular ratio and a unit rate, which is still a ratio, but just a special type of ratio. And in the next video, we'll learn how unit rates help us solve problems. But for now, let's just focus on how to find a unit rate. Okay, so let's look at two related examples. This example says, a person runs 10 miles in 2 hours. How many miles does the person run each hour? In other words, what is the miles per hour of the person running? Miles per hour is one of the most common unit rates because everyone has experience at some point in their life with miles per hour. So first, let's set up a ratio. We have to look in the problem, and what we'll see is that the problem gives us some information. The information that the problem gives us is that the person runs 10 miles in 2 hours. So first, what I did here is I just made a model to represent that. I did 10 little blocks to represent 10 miles, and that person runs those 10 miles in 2 hours. I even set up a ratio, 10 miles to 2 hours. You can always look into the problem to find the ratio to set up as your starting point. In this case, the ratio is 10 to 2, 10 miles to 2 hours. Once again, 10 miles for every 2 hours. 10 miles, 2 hours. When setting up your ratio in order to find the unit rate, it's important to use labels such as miles and hours. And you can abbreviate them like I did here, MI for miles and HR for hours. Well, how do we find how many miles in each hour? Well, our question is, how many miles will there be in 1 hour? So eventually, we're going to get another ratio. How many miles will there be in 1 hour? Okay? So we set up our problem like this. And what you can see, in order to figure this out, and when I give the students a model like this, a lot of them naturally do this. They'll split the hours up so that there's 1 hour in each group, and then they'll split up the miles evenly to see how many miles go for each hour. And what you'll notice is that if there was 10 miles for the 2 hours, each hour is going to have 5 miles in it. So we can see that this person runs 1, 2, 3, 4, 5 miles every hour. But how do we figure that out mathematically? Well, Again, first look at the question. The person runs 10 miles in 2 hours. So we set up our ratio, 10 miles to 2 hours. That is our starting ratio. But then it's asking how many miles, question mark miles, does the person run each hour? Each hour. And each means every 1 hour. Since it's the hours, okay, that we're looking for, how many they're running in each 1 hour, we take our number for hours and we divide both parts of the ratio by the number that represented hours. So we're actually going to divide the miles and the hours by 2. The reason we're choosing 2 to divide by is because we started out knowing that they run 10 miles in 2 hours, but we're choosing the number 2 because the question is asking how much they run in each 1 hour. So we choose the number that related to the hours in our starting ratio, which just happened to be at 2. So we divide both by 2, and that's technically what I did here. I took the hours and I divided them into 2 parts, giving me 1 hour in each group. And then I took the 10 miles and I divided them into 2 equal groups, 1 group for each hour. So I just do my math. 10 divided by 2 equals 5. 2 divided by 2 gives you 1. So 10 divided by 2, and I took those 10 miles, they were together, and I split them up into 2 groups. 10 divided by 2 is 5. 2 divided by 2 is 1. So each group has 5 miles, 1, 2, 3, 4, 5, and 1 hour. So we can say that the person runs 5 miles each hour, or per hour. Okay, let me just write that down here. Okay, we found the unit rate. This here was a ratio, 10 to 2. That's what we started with. But after we divided by the number of hours, divided both by 2, we got 5 miles in 1 hour. This is our unit rate. Okay? This is a ratio, and this is a unit rate. It's also a ratio, but one of these numbers is a 1. 1 hour. 5 miles per hour. All right, let's look at the same example, but let's look at it from a different way. A person runs 10 miles in 2 hours. So if you'll notice, we have the same picture we started with last time. 10 miles in the span of 2 hours. And we started out with the same ratio, 10 miles to 2 hours. This is just a ratio. This is not a unit rate yet because neither of these numbers is a 1. So this is just our starting ratio, and we got this from the problem. The person runs 10 miles in 2 hours. Now we must read the question. It's very important to read the question because we're going to change the question slightly from the last example. This time it's asking how many hours does it take the person to run each 1 mile? In other words, hours per mile. So this time, we're looking for how many hours does it take to run 1 mile. This time, since we are looking for how many hours in just 1 mile, we're going to use this number to divide now because it's the miles we're looking to become that one, that unit as we call it. So this example, we would be dividing by the miles, by 10. Because the question is asking how many hours, we don't know how many hours, does it take to run each 1 mile. So whatever the question is asking, that's why it's important to put your labels. Whatever the question is asking for one of is the number that we divide by. In this case, it's asking for how many hours in each 1 mile. So we pick the miles number this time, which is 10, and divide by that. So, if you think about it, we're looking at each mile, what part of the hour does that represent? Whereas last question, we were looking at how many miles go with each hour. And if you'll notice, each 1 mile represents just this little piece of an hour. So just by using your number sense, you can think that each mile will take less than an hour to run. If they can run 10 miles in 2 hours, each mile is going to take less than an hour. But exactly how much of that hour? Well, let's do our division. 10 divided by 10 is 1. So we have our 1 mile. But 2 divided by 10 will come out to 0.2, or in other words, 2/10. So we could say that this person will take 2/10 or 0.2 hours to go, and sorry, it's slow for me to write on this, I'm using my mouse, to go 1 mile. So it's important for the students to see the difference in the two problems that we just solved. Both problems start the same way, saying that a person runs 10 miles in 2 hours, and in fact, we start by setting up the same ratio, 10 miles to 2 hours. But the first example is asking how many miles does it take to go, per hour? How many miles does the person run each hour? Since we're looking for each 1 hour, we divide the ratio that we started with by the number that we used for our hours, which was 2 in this problem. And we find that we got 5 miles per each hour. Whereas our second example started the same way, 10 miles in 2 hours. But now we're wondering how many hours does it take the person to run each 1 mile? So in the second problem, we're looking for each 1 mile. So that's why we divide by this number, the miles number, which is 10. Okay? So, when we do that, we get that 1 mile, it takes them 0.2, or in other words, 2/10 of an hour. Okay? If that's a bit confusing, let me give you an example, okay, that was in the homework. Okay, so if you just give me a moment, I'm going to get the homework page up here. The very first question in the homework. Okay, and what I'm going to have to do is I'm going to have to flip back and forth between these two screens. It costs $23 for 5 tickets to the concert. Okay, and then it asks, what is the price for 1 ticket? So, we can start out by making a ratio. $23, okay, for 5 tickets. $23 for 5 tickets. So that's our starting ratio. 23, and I use my dollar sign, for 5. I'm just going to put TIC for tickets. $23 for 5 tickets. Then we have to think. In order to figure out what to divide by, we have to read the question. What is the price for 1 ticket? Okay, it's not asking for $1. How many tickets can you get for $1? It's not asking that. It's asking what is the price for each 1 ticket. So we take our number for the tickets, which is 5. 5 tickets. And that is going to be the number we use to divide the entire ratio by. So divide both top and bottom of the ratio by 5, and it'll make our unit rate. 5 divided by 5 gives us 1 ticket. And again, I'm just going to write TIC because you can abbreviate. Okay? And then we just do $23 divided by 5. And what you'll get is that each ticket costs $4.60. Okay? When your student does this in the calculator, 23 divided by 5, they're actually going to get 4.6. Just remind your student that when we're working with money, you always have to add a second decimal place. If there's only one decimal place, such as 4.6, if it's working with money, we got to add that 0 to make it an actual money term. $4.60. Okay, so if there's $23 for 5 tickets, that means it's $4.60 for each 1 ticket. Okay, if you have any questions, email me or give me a call. I'll be glad to help. Have a great night.